So my goal in this video is to look at the topics that appear in the second semester general chemistry course that I teach and to think about how we should begin to sequence those within this course, within Chemistry 6088. Should we go in the same order that I have them within my course, or do we want to make a different decision? I list this objective. This is an objective for Chemistry 6088. Topics pertaining to equilibrium, such as solubility and acid-base chemistry, will be investigated and described using kinetic and thermodynamic-based explanations. So what we have here is the idea of various topics pertaining to equilibrium. How do they then connect to the topics of kinetics and chemical thermodynamics? That's a really big objective for us here in 6088. That's the central objective, I would say. So what we want to do is consider the second semester of the general chemistry course that I teach. What topics are found in that? And in particular, let's look at the placement of kinetics, chemical thermodynamics, and equilibrium, because those are what we're trying to bring together within this course. So let's see where those ideas fit and where we might want to place them within this Chemistry 6088 course. So here's the distribution of topics for my one-year general chemistry class. Everything on the left column, that's in the first semester, Chemistry 1210, everything on the right within the second semester. The exams that I have typically in the second semester, when we divide it up to have 3 different exams. First one looks at properties of solution and kinetics. The second one, aspects of chemical equilibrium, introduction to acids and bases, and then this Chapter 17, additional aspects. We do the first part of that involving things like buffers and titrations. Third exam, we have quite a few different chapters, but we don't give the same degree of attention to all of them. For the additional aspects of aqueous equilibria, we look at aspects of solubility. We look at chemical thermodynamics, electrochemistry. Those would be the main themes. Nuclear chemistry, that's not typically on the third exam. It might be appearing on the cumulative final though. And same thing with transition metals and coordination chemistry. It's in the back portion of the course. Sometimes it's on the third exam. More often though, it's something that appears on the final. The other topics that you see there, chemistry of the environment and chemistry of the nonmetals, of late that hasn't been part of the course. So within Chem 6088 here, the topics that we're going to be taking up are those found in chapters 13 through 17, and then also the thermodynamics. And remember, we want to look at these and connect the topics of equilibrium to the explanations that we can provide using kinetics and thermodynamics. The placement of these, it's not the same in every textbook. This idea of thermodynamics and kinetics, notice when thermodynamics is placed after equilibrium, you don't really have that in your tool belt when you're seeking to explain aspects of chemical equilibrium. You sort of have to do just hand-waving things pertaining to entropy. When I look at this sequence within other textbooks, you find differences in other textbooks for where things are placed in the first semester. For example, thermochemistry sometimes is shifted downward, occurring later in the semester. There's other examples where the topic of gases is moved upward, sometimes before thermo, sometimes after. In an Adams first approach, we have this whole description, our sequence going from electronic structure to bonding that's placed before reactions. But notice in all of those, we weren't making any changes to the sequence within the second semester. In a somewhat more advanced book like Petrucci, there's a small change within the first semester, and then there's a switch. There's a switch where the chemical thermodynamics is at the start of the second semester and kinetics is moved down. Perhaps the largest change is in the Atkins textbook. Within Atkins, he has this first section on fundamentals, which are a whole host of ideas that you might think, well, that's my entire course. Within his course, his textbook, this is what I use within my honors course, those are the things that we don't really cover. they're considered, if you want to say, prior knowledge of the students. It's an atoms first approach then that looks quite deeply compared to other general chemistry textbooks into aspects of quantum mechanics. It moves from that then into bonding, different states of matter. Thermochemistry is found, and the thermochemistry there is also then linked with entropy and the Gibbs free energy. So all of that is appearing in this focus number 4. With that information, that then sets up a discussion of aspects of equilibrium and whether it's physical or chemical, and then it's applied for the different types of reactions. Might be acid-base, might be electrochemical. And then finally, it gets to a description of kinetics. Now, Atkins then, similar to Petrucci, is putting kinetics following equilibrium and moving up then this thermodynamic explanation. But he tries to support both of them. When the topics come up, he has these sections. Well, what if we wanted to explain this using kinetics? What if we wanted to explain this using thermodynamics? He uses that when describing vapor pressure, when describing different aspects of equilibrium. Notice how it gets more and more involved. It gets a fuller description here of a kinetics description and a fuller description using thermodynamics. He wants to provide the instructor the choice of which path they want to take. So as I look at this then, and I'm thinking then about Chemistry 6088, what path do we want to take? Well, one thought is it would be beneficial to put both of these topics, both kinetics and chemical thermodynamics, before we get to the actual phenomena. What would it mean to use our own prior knowledge? We already know things about acids and bases. Let's put the description here of the tools that we want to use, the chemical thermodynamics and the chemical kinetics. Let's consider putting those before the phenomena so then we can have it as we seek to construct explanations. Let's equip ourselves so we can use both types of these explanations, not just one of them. You know, as I look at different treatments of thermodynamics and kinetics, it's in an interesting way it appears in organic chemistry textbooks. So here's one that I just grabbed where it points out as a reaction progresses, you might have an initial starting material and you have different possible products. A picture like this, a diagram like this is given a thermodynamic description because it is just showing where you start and where you finish. That's the domain of thermodynamics. And it's given an analysis and saying, well, what would be the change in the Gibbs free energy between these? Here's another image from the same textbook where it's showing now in the reaction progress diagram what takes place in between energetically, between the start and the finish, between the initial and the final. This idea of ignoring all of that in between, just blocking it out, that's what happens with thermodynamics. With thermodynamics, it's all final and initial states. You're not asking about the in-between step. The in-between, that's the domain of kinetics. Within the organic textbook, it points out in an interesting way, there's times that you'd have reactions where it's not favored in terms of both the kinetics and in terms of the thermodynamics. Look within the two images right here. In the one on the left, we have a case which is more typical, where we have a product that's favored both thermodynamically and kinetically. But there's examples where that's not always the case, and in a clever way, this is something that an organic chemist can use to try to favor one product over a different one. Now, we're not going to favor one product over a different one, but we need to decide if we're going to put kinetics and thermodynamics at the start of the course, well, which one do we put first? Now, if I look at these diagrams, notice how the energy is the Gibbs free energy. This vertical axis of energy, if we look more closely, they're talking about the Gibbs free energy. So that suggests to me that if we're looking within our own course right here, I think we got to put thermodynamics first. Because if the in-between step here, if the kinetics requires an understanding of the Gibbs free energy, I think we need to have that in our toolbox before we look at the kinetics. So my plan then here is, let's shift both the description of thermodynamics and kinetics before the other phenomena. Let's put the thermodynamics portion very first in line. From there, we'll then explore ideas involving kinetics, and with that then we'll explore the different topics that we have. And when I say we'll put those first, let's do this as teachers. Let's not say, all right, well, we're going to forget everything we know about chemistry. Let's keep our own knowledge of chemistry, but add to it now a description of thermodynamics and kinetics, and then build from that to be able to reach our objective of being able to explain phenomena involving solubility and acid-base chemistry using either thermodynamic or kinetic-based explanations.